Hello YouTubers, I'm Jishin Desai, the founder of Amba Academy, and today we are going to discuss about atomic structure. Now before we actually jump into atomic structure, it's really important that we study some fundamentals of atom. So before we actually jump in, like how atom is structured, like how exactly atom looks like if we jump into atom, how it looks like, what are the components that make up the atoms. Like before we jump into that part, we actually need to have basic idea, like basic theories that would help us to get there, that will help us to enhance our uh, understanding power to get that information correctly. So before we jump into like directly into atomic structure, we need to know two basic things, two basic right, two basic things, like two basic kind types of theories, and you can see it right here. It's foundation of atomic theory and Dalton's atomic theory. And what I have done for you, I have made it like super easy. Like I have made it, like I have organized it so it's like kind of super easy for you guys. You can clearly see it from here and you can understand the things. Now before we actually jump into it, let's just get like quick review, not exactly a review, but let's kind of get a brief uh, explanation of what was going on during this time. So who was the first person who discovered atom? So atom was first discovered by Democritus, who was a Greek philosopher, and he told that is atom is anything, like atom is the smallest constituent that makes up a matter. So let's make it even simpler. So every matter in this universe is made up of small particles called atoms, and atoms are indivisible. That's what Democritus told. But Aristotle and Plato, other two big not Greek philosophers, but other two great philosophers, they didn't believe his idea. They were like, nah, he's not good. His idea doesn't sound good. And as they were big philosophers, people followed them and they told atom doesn't exist. So for 1,000 years, we the chemistry was like we don't have any atoms. And then like during 18th century, people started scientists, not people, scientists started researching about it, and they found, yeah, atoms do exist. They actually told, yes, Democritus was correct, atom do exist. Now as soon as the people came to know that atom do exist, people started researching on it, and through that we came to know the foundation of atomic theory. And then Dalton's atomic theory is proposed by the person named John Dalton, right? He is an Englishman, lives in Great Britain. He used to live in Great Britain. So yeah, Dalton's atomic theory. So that's, and John Dalton, most important thing you need to know, is known as the father of atomic theory. So if someone asks you who's the father of atomic theory, it's John Dalton. That's, and this, due to this theory, he is named as like the father of atomic like he is atomic chemistry, atomic chemistry. That's the reason he's known as the father. All right, so let's jump into foundation of atomic theory. So when you study foundation of atomic theory, it's simply divided up into three laws. That three laws you need to know. So law number one is law of conservation of mass. Law number two is law of definite proportion. Now this law of definite proportion can be also said as law of definite composition. You can also say it that way. And the last one is law of multiple proportion. Now when we look particularly at law of conservation of mass, what is law of conservation of mass? So law of conservation of mass states that um, the total mass before the chemical reaction and after the chemical reaction takes place remains the same. That means, like, when we look at chemical reaction, right, so we see something like, right, so what we do when we see chemical reaction, right, let me give an example right here. So when it could be like, sorry for bad handwriting, it could be H2O plus O, and then it gives you, or let's take a simpler example. All right, let's do what? Let's take up a simpler example. Um, let's say H2, right? That sounds simpler. H2 plus O2 will give me what? Will give me H2O. So in this case, right, this portion, this H2 plus O2 is known as reactants, and H2O, what we got, is known as product. So if we relate this to law of conservation of mass, the mass of reactants H2 plus O2. So the things that are reacting are reactants, and the thing that is formed, this H2O, the compound that is formed as the result of the reactants, right, due to the reaction of reactants, right, that's the product. So H2 plus O2, what are this? These are reactants and H2 is product. So so H2 plus O2 are the reactants. Now, the law, according to the law of conservation of mass, H2 plus O2, the mass of H2 plus O2 should be the same as mass of H2O. That means the mass of reactants should be equal to the mass of products. Mass of reactants should be equal to the mass of products. That is what stated under the law of conservation of mass. Now when we look at law of definite proportion, or you can say law of, right, if you see it, say it is law of constant proportion, even that sounds good. Law of constant proportion, it sounds good. Law of definite proportion also, it sounds good. So what exactly it is? So law of definite proportion, it actually states that the chemical compound contains the same elements in exact same proportion by mass, regardless of size of the sample or the source of the compound. So if you, like, you might be confused, what is this talking about? So let's take a simple example. Let's take up a simple example. Let's say Na plus, right, it reacts with Cl, that is chlorine minus, will give me what? Will give me NaCl, that is the table salt. That means when sodium ion reacts with chloride, it should give me common salt. Now when we look at this, Na plus Cl minus, this is reactants, and table salt NaCl is what is the product. Now when you look at it, the Na by mass, right? If you see the mass of Na, it constitutes 60.66%. Oh, my bad, sorry. Na constitutes 39.34% of the total mass, and chloride consists of 60.66%. So it says, like, it, that means the mass is what? Fixed. The mass is not fixed, but the abundance of the mass is fixed. All right, the mass of abundance, how much abundant it is, that much amount is what fixed. That's what definite proportion is. Like only this much. If you are making NaCl, only this much percent. In this case, it's 39.34. So only this much percent of NaCl, and 60.66. Only this much percent of Cl. Only this percent should work to give you NaCl. That's what it is talking about on the definite proportion, right? Law of definite proportion. Now let's jump down to law of multiple proportion. Multiple proportion states that if two or more different compounds are composed of the same elements, so if two or more compounds, so let's take a quick example again. H2 plus O2 should give me what? H2O, and H2 is what? Water. Similarly, let me take another example over here. Similarly, H2 plus O2 can also give me H2O2. It can give me H2O2. Alright, so these are, now you'll be saying, okay, we are using the same elements but the compounds are different. So in this case, when the elements are same and the compound form is different, then the ratio of the masses of second element, right? So in this case, the ratio of the second element, in this case what it is oxygen. All right, it is what? Oxygen. The ratio of second element, right? The ratio of mass of second element combined with certain mass of first element. All right, so ratio of this second element in this case is what? Oxygen. So ratio of oxygen here, even here ratio of oxygen combined with the ratio of certain ratio of the first element. So if you take the ratio of oxygen and the ratio of hydrogen, it should give you what? Same ratio. Not the same ratio, I mean. So if you take the ratio of oxygen and the ratio of hydrogen, it should give you the ratio in the small whole number. All right, it should be small whole number. The ratios form will be in small whole numbers. That's what it is talking about. Multiple proportions, multiple proportions. So you can even say multiple means multiple compounds are formed but with the same elements. Now if that is the case, always the mass of the ratio of the mass of second element to the mass of the ratio of first element, right? When you combine those, it should give you the ratio in what? It should give you the ratio in small whole number form. That's what law of multiple proportion is talking about. Now let's jump down to Dalton's atomic theory. So when you look at Dalton's atomic theory states four postulates. So postulate number one states that all the matter is made up of indivisible particle called atom. Alright, so whatever metal you see on this planet Earth or in the universe is what? Made up of atoms. And atoms are what? Indivisible. That's postulate one. Postulate two states that atoms of same elements are identical in shape and size. So if you see element nitrogen, all the elements or all the atoms of nitrogen will be what? Identical in shape and size. So the shape and the size of nitrogen will be same. Not nitrogen atoms will be same. Similarly, when I see carbon, all the atoms of carbon will have same masses and same sizes. All right. So and then if a chemical reaction takes place, right, we just took the example of H2 plus O2 giving me what? H2O. So when a chemical reaction takes place, the atoms are not created and they are not even destroyed. Alright, so atom cannot be created nor be destroyed. It can just be transferred. It can just be transferred or rearranged. Right? It cannot be created nor be destroyed. It can just be rearranged, or you can say it can just be transferred. Now compounds. So if you just look at H2O, what is this H2O? H2 is H2O. H2O is a compound. So this H2O compound is formed by combination of atoms, hydrogen atom and oxygen atom. When they combine together, they form what? A compound. So compounds All right, we saw the example of so table salt NaCl. So Na is a compound, Cl is a compound. So Na. So when two, oh sorry, Na is a element, Cl is a element. So when two different elements combine, a compound has been formed. So that's what postulate 4 is stating. Compound are formed by the combination of one or more atoms. Uh, Thanks. That's it for today. I hope it helps you. And this was just like a trial. If you get it, that's the reason it's long. Otherwise, the videos will be short like just for 5 to 6 minutes. Alright, thanks. I hope it helps you.